Hi, everyone. I'm Brian Raymond, founder and CEO of Unstructured. And today I'm here to talk to you about how organizations can harness their data in conjunction with generative AI, and in particular, natural language data. So let's dive on in. So Unstructured, we're about a 16-month-old company. We've started open source. And so since this last April, we've had about 3 million downloads. We're used in approximately 10,000 code bases. And we have users from across approximately 13,000 companies using us today. To get started, if you want to follow along behind the scenes, feel free to go to our website and grab an API key. You can use our API for free, or you can pip install our Python library. Let's dive on in. So here at Unstructured, our mission is to help you get your data LLM ready, and this encompasses all of your data, your natural language data. So whether or not it's stored in PowerPoint, HTML, Word documents, Slack conversations, we wrap our arms around all of it and help transform it into clean JSON that's ready for a model endpoint. So why is this important? Well, with LLMs, you have 3 big challenges on using an off-the-shelf LLM in conjunction with your data. One, they're frozen in time. And so if you're able to bring your data to the model, it's never out of date. Second, as we all know, they're prone to hallucinations. You can help ground those and mitigate those hallucinations if you anchor it on your data and force it to return inferences that are based on your data. And 3, these are general models. They know nothing about your specific organization or domain. And so you're able to augment their knowledge in a RAG architecture without having to fine tune, but you could also encode it in the model through fine tuning or pre-training. Unstructured is relevant to all 3. And so where do we sit? So on the left, you have natural language data. It can be in any file type, could be in any document layout. We'll talk more about that in a moment. And by and large, folks are using us today to get their data into vector databases, so JSON and vectorized representations of that text, so that an LLM, when prompted, can go and retrieve relevant data from that vector database and incorporate it into the answer. And so let's dive into some of the challenges of getting that data ready. So when we see a PowerPoint slide, we automatically recognize the author, the presentation name, the section, the page number, etc. When a computer sees a PowerPoint slide, it sees ones and zeros. So over the last 5 to 10 years, we've gotten pretty good at training models to understand slides, document layouts of all different types. And these work really, really well when information is consistent. So for example, if you have 100,000 invoices or bills of lading or customs forms of some type that have a very consistent document layout, we've gotten pretty good at extracting and rendering that data. However, as humans, we're rarely consistent. A lot of our users, instead of having 100,000 files that are all identical, have 100,000 files in a folder that are all different file extensions and have incredibly varied document layouts and languages within them. And so how have data scientists grappled with this? Well, this is kind of the dirty secret of NLP. It's been through regexes, it's been through Python scripts, it's been through hacking OCR pipelines together and then hard coding them to particular document layouts. And as document layouts change, everything breaks and you got to do it over again if you want to render clean data. And so this has meant huge professional services bills if you actually want to use your natural language data in conjunction with machine learning models. And so that's just PowerPoints that we were talking about. What about all the other long tail of file types that we encode our natural language in large organizations? With Unstructured, this is our central challenge. This is our mission, is to be able to take any document, any file type, any layout, and you can just send it to Unstructured, and what you get back is clean JSON that's ML ready. And so if you already have your data in JSON, unfortunate thing is you're still not home free yet. You may not have accounted for reading order. Basically nothing on the market off the shelf can naturally intuit the natural reading order of documents. For example, or chunking. Chunking is a hot topic right now. Most everyone's using a rolling chunking approach. With Unstructured, we are understanding what are titles, what are subtitles, what's body text, what are tables, what are forms, etc. And we're able to do context-aware chunking, so all of the relevant data is included in that chunk. Additionally, as an industry, we're moving towards metadata filtering and using metadata to do enhanced retrieval. We're not only pulling across the metadata that already exists from systems of record, but we're also generating proprietary metadata to further enhance the quality of the retrieval so that you're able to deliver exactly the payload that you want to the context window when you need it. And so it can keep costs down and performance high. And so at Unstructured, we're spending a lot of internal R&D on the metadata, on table extraction, on chunking, on reading order, and a whole host of other challenges within this domain, so that you're not giving up anything in terms of data quality and pre-processing when you're populating your vector database. So what's this look like in terms of logical architecture under the hood? Well, you can use Airbyte connectors. We have a number of connectors that we offer as well. And so you can pull data from those systems of record. We support ingestion of approximately 25 different file types. Our system automatically routes those files to the optimized pipeline that balances speed and quality. And so if we already have access to the text, we're not going to send it through an expensive vision transformer model, for example. We'll render everything in a consistent JSON format. We'll help you chunk it. We'll help you create vectorized representations of it. And then you can write those payloads down to a vector database, again, using our connectors or Airbyte connectors. And so zooming out one level, so unstructured, we're extracting, we're transforming, we're staging that in vector storage. And so from unstructured, most folks are sending it to an embedding endpoint as well as a vector store. And then you can use an orchestration framework like LangChain, LlamaIndex, Haystack, et cetera, at an LLM endpoint in order to continuously hydrate your LLM with recent, relevant, and validated data from your organization. And so let's dive in and show you how you can actually build a data profile with the unstructured platform. So in this case, we're creating a source. This is going to be pulling from an S3 bucket. And so we'll create the source. Again, you don't need to worry about building the connectors, just inputting the right information. We're now creating a destination. So we'll write to your preferred vector database. In this case, we're choosing Pinecone for sake of the demo. And so once you've established the upstream and the downstream locations, you can create a profile here. And so you can schedule how the periodicity of when you want to pull from, in this case, S3. You could also hardwire the strategy, so have it go automatically to one of those expensive models, or you go auto strategy. You can also clean out data really efficiently using our metadata, choose a chunking strategy, choose an embedding endpoint, and then just set it on cruise control. And now unstructured is running behind the scenes, continuously populating that vector database with net new information from your systems of record. And so it's as simple as that on setting up a data profile and getting it going. This is in private beta right now. Feel free to reach out and we can get you set up with an early account. So let's go to the next slide here and transition. On our side, one area that we wanted to kind of dive into here was on table extraction in particular. And so on table extraction over here on the left, this is like a typical like S1, 10K, 10Q filing. And if you were to use a typical table extraction model, so for example, like Camelot or even GPT-4 for some of these things, or Claude, you're going to have a lot of challenges on extracting these tables. We're training proprietary table extraction models that go far beyond anything on the market right now, so that you don't have to deal with character spacing or shading issues, and then we can render it in HTML in this case, so that you can deliver it into the vector database, and the LLM can do that. And so it's these edge cases that really challenge most of the workflows today around LLMs. So around question answering tasks or information retrieval tasks, where you need to be very, very thoughtful about stripping out noise, but then also accurately rendering that JSON. In this case, accurately rendering the table, but also reading order, understanding hierarchy, and stripping out unnecessary information in order to maximize the performance of that LM in these architectures. So thanks for your time today. If you'd like to learn more, feel free to go to our GitHub, unstructured-io, join our Slack channel, or email me, Brian@unstructured.io. Have a great week.